Hello and welcome to another one of these ADD videos. Today we're going to be looking at a special class of reactions called Markonikov reactions. When we're looking at an alkene, the electrons of a pi bond can be considered as electron donators to form a bond with an electrophile. This is a process called electrophilic addition. And what happens is your electrophile will come in and bond to the pi electrons. When you first see it, you probably see it as a hydrogen as your electrophile, but basically what we got going on is like the nucleophile and base we just studied for substitution and elimination reactions. They were electron rich. Alkenes are also electron rich. If you want to think about the electrons in the pi bond, we've got extra electrons that can form bonds. So the Markonikov rule states that, this is the expanded rule, states that it will take place in two steps, and the first of which is to form the carbocation. And the rule states that it's going to bond the electrophile in order to form the most stable carbocation. So the rule states that the initial binding is going to be done in a manner in which you're going to get the most stable intermediate carbocation, free radical, whatever it is. This is the expanded version of the rule. The regular rule is going to say that the hydrogen is going to bind to the carbon of your alkene that already has the most hydrogens. That's how you're going to start out with it. So here's your alkene. Notice it's asymmetric, meaning that there's a methyl on one side and then two hydrogens. So there's going to be a preference when you add this HBr. All right. So if you look at this hydrogen bromide bond, but here you're going to see that the hydrogen here is not as electronegative as bromine. So therefore hydrogen has very little electron density, right? The electron probability of being around hydrogen is far less than bromine. That results in a partial positive charge there, partial negative charge on the bromine, and the partial positive charge is making that very electrophilic. So the hydrogen can bind and form a carbocation. All right, so in this case, the hydrogen binds to the side that has the most hydrogens so that we can form the secondary carbocation. If I'd put the hydrogen on this one, it would be primary, and that's not as stable. If you remember, it's 3-2-1. So again, hydrogen binds to the side with the most hydrogens. This is for Markonikov. Hydrogen to the most hydrogens. Then what that leaves is a carbocation that's secondary. So here's our hydrogen that we were looking at here. It's bound to the side with the most hydrogens. And now we have a bromine that's left with a bunch of electrons, and this bromine can come and bind here. All right? So the product that you get would be this. All right? So this is referred to as Markonikov orientation, in which the electron-rich species is bonded to the more substituted carbon of the double bond. Again, the best way to look at it is the most stable intermediate, which requires you to know that the secondary is more stable than the primary. And if you want to just look at basic Markonikov, think of it in terms of hydrogen binds to the side of the alkene that's got the most hydrogens. Hydrogen is your electrophile here. All right, so two-step process again. You're going to get either a carbocation intermediate for Markonikov reactions. There are other reactions that you might get a cyclical intermediate, okay? But basically, this is the general rule. You're going to want to form the most stable intermediate. There's also anti-Markonikov reactions, and that's the opposite of this orientation, in which the electrophile would be bonded on the least substituted carbon. And what happens there is dependent on which of the two anti-Markonikov reactions we're going to discuss. One is hydroboration, and the other one is addition of HBr, but then in the presence of peroxide. So those are the only two that are anti-Markonikov. The rest will be Markonikov, all right? So make sure you check out the example videos for the different types of Markonikov reactions. I'm going to try to do as many as I can for the specifics, but this is just your basic introduction one. So I hope I've clarified things enough for you to try them on your own. Again, most stable intermediate is what you want. Thanks for watching. Practice, practice, practice. Check out the example videos, and have a great day.